Hi Geometry, this is Unit 6, Lesson 1, page 649 of our workbooks. So in this first activity, I want to know how far is point A from point B. So from point A, let's connect it. If you've got a ruler handy, use a ruler, make a nice straight line. So one thing that we could do to find the distance here is actually use our Pythagorean theorem skills, because if I connect A and B using a vertical and horizontal line, I create a right angle and I create a right triangle where the red side is my hypotenuse, and I can see that this vertical side is 3 squares tall, and I can see that in total 1, 2, 3, 4, this horizontal side is 4 squares across. And so I could use my Pythagorean theorem. I know that my hypotenuse has to be my c, so my a squared plus b squared equals c squared, where my a and b are my two blue legs. It doesn't matter my order, so I have 3 squared plus 4 squared equals my red side that I don't know. And so in this case, you could call it, let's call it x for right now, but you could also call it AB. We'll say that's x squared. So that's my triangle up on my grid. And let's do that math. I get 9 plus 16 equals x squared. I get 25 equals x squared. Now I take the square root of both sides, and I find that the length of that side is 5 units. It says what transformation will take point A, so this is where you're starting, to point B, so that's where you're ending. So if you remember last semester, that was a translation. That was my slide across from A to B. So this is from A, which is -3, 5. Remember, it's your x coordinate first and then my y coordinate, to B, which is located at 1, 2 on my graph, 1, 2. So then let's take a look at this next activity. So first of all, this activity can be done with patty paper. And I think for a lot of kids, it makes it easier when you can actually physically move the H, this like little quadrilateral, four-sided quadrilateral around with patty paper. But we're gonna do it without patty paper for this video. I'll show you how to do patty paper in Zoom in class. So it says to rotate figure H clockwise. That's important. So clockwise is the direction my clock goes. Around center to 0. Okay, that's different. This center to 0 is different. It's not the origin. So this is my center. So basically, I'm going to pivot this blue shape around my blue center that you see here. I'm going to be spinning it around by 90 degrees. So I'm going to spin it around clockwise 90 degrees. Well, the cool thing about 90 degrees is I can visualize that because it's right angles. So first of all, this blue side, if I move it 90 degrees, it would go from being vertical to horizontal. So actually, it would become this side right here. This point would be right here. So I've moved one of my sides. Another side I can move if I go get red. This original side, if I move it 90 degrees, it would move from being horizontal to vertical. And it would be pointed down and would also be 2 units long. So then the other side would move with it. If you can imagine, let me get a different color. I've got this side, which is vertical. It would also swing down and become horizontal, but it was 2 units away from my center. So it'll be 2 units away from my center, and it was 3 units long. So it would be this segment, and then this diagonal segment that you see right here, just connect those 2 vertices. So I'm just going to connect these 2 vertices, and I'm going to go back and erase my original one, and then I'm going to draw in my new one, and we can take a look at this. and see that my red figure is my blue figure, we'll call it H prime, but that's been rotated 90 degrees clockwise. This clockwise direction, 90 degrees. Again, it's a little easier with patty paper. We'll look at it in Zoom, and when you're in the room, if you don't have any patty paper from last semester, you can get a couple new sheets. So now it wants me to translate. Remember, to translate is my slide by directed line segment from 2, 0 to 3, negative 4. So let's find out what that is. So 2, 0 is my red point right here to 3, negative 4. So this red point is going to go to 3, negative 4. So I want to slide my entire red figure down this same movement. Again, this is where patty paper makes visualizing very easy. But if you can imagine, I'm going to slide this entire side down. So there's that side. Then I have this this vertical side coming down from it, 2 units. That's that side. Then I have this side that was 3 units, 1, 2, 3. Then I have my side that connects those 2 points. So I visually moved it. We'll call this H double prime. Oh, it says to label the result R. So let me erase that real quick and label my result R. So redraw it in. And this is my result R. So then let's take a look at reflecting figure H. Notice we're going back to the blue one across the y-axis. So again, you could do this with patty paper, but I actually do this without myself. It's 2 units to the right of the y-axis. So this is going to move this 2 units to the left. This is 1, 2, 3, 4 units from the y-axis. So 1, 2, 3, 4 units from the y-axis. This point is 2 units. So 1, 2. Notice I'm just, this one is 1, 2, 3, 4. So I come over here, 1, 2, 3, 4. And I have reflected H across the y-axis by just moving my points to the same amount on the other side of the y-axis. Next, it says rotate the image counterclockwise using center 0, 0 by 90 degrees. Label the result L. So I'm actually going to give you a rule to help us here. If you're using patty paper, we could do it that way. But in absence of patty paper, there is a rule for rotating clockwise around the origin, that's important, by 90 degrees. It wouldn't have worked in number 1 because I was using 2, 0. But if you're using the origin, it takes all your coordinates, x, y, and it moves them to negative y, x. In other words, I flip-flop my coordinates and I make my coordinate now in the x position negative. So let me show you doing that with some of these coordinates. So I'm going to go around this figure. This is negative 2, 0. Remember x first. This is negative 4, 0. This coordinate is what? Negative 4, 3. And this coordinate is negative 2, 2. So those are my 4 coordinates that I'd like to move 90 degrees counterclockwise. So then, for example, when I put my negative 4, 3 in here, if I flip them, I get 3, negative 4. And if I make the first one negative, it becomes negative 3, negative 4. So let me go find that. Negative 3, negative 4. 1, 2, 3, 4. So that means this red dot goes to there. So now let me get a different color. Let's do the negative 2, 2. So we're going to do this one next. And so now let's flip-flop them. 2, negative 2. And let's make the first one negative. So then that point's going to go to negative 2, negative 2. So over negative 2, down negative 2. So the blue dot goes to the blue dot. Let me grab a different color. Let's go do this one next, the negative 2, 0. So negative 2, 0. So I'm going to flip-flop my x and y. And when I make my first one negative, it doesn't matter because it was 0. So this is going to go to 0, negative 2. So 0 in the x direction means I don't move left or right. And I'm just going to go down negative 2. So my green one goes to the green one. And let's go grab yellow, and we'll do my final coordinate. you can almost see where that one's going to go. I can tell it's going to go right here. But let's go get that. So that was -4, 0. And so when I flip-flop them, I get 0, -4. And when I make the first one negative, it doesn't matter. And so then I can see that my new figure, when I rotate 90 degrees around the origin, is this yellow shape right here. We'll call it L. And you can see between my green dots, you can see the 90-degree angle. Between my blue dot, which just got covered up, you can see my 90-degree angle. So I could go around with each of mine and see that. Okay. So again, patty paper is another way to do this problem if you had it as well. So on this activity, we are going to work with two different triangles. Why don't you divide your workspace in half? And on this side, we're going to do triangle EDF, the green one. And on this side, we're going to work with triangle B, how did I go? EDF. So we're going to call it BAC. Okay, you guys, so let's first go back to the green one. So for A, it says calculate the length of each side. So ED, EF, and DF. So first of all, the vertical and horizontal sides are easy. This is 2 and this is 3. So I know that EF is 2. I know that ED is 3. So now I have to find DF, and I can use my Pythagorean theorem for that. I know that my leg squared is going to equal my DF, my hypotenuse squared. So 4 plus 9 is 13. That's my DF squared. So it looks like DF is the square root of 13. So you could write that as the square root of 13, or on your calculator, you get approximately 3.6 units for that. So either one is what you can put in up here. So now let's look at the blue one. Let's do my same sides. So my first side I'm going to do is my AB side, and then I have my BC side, and then finally I have my hypotenuse, which is my AC side. So AB I can see, because it's horizontal, is 3 units. BC I can see, since it's vertical, is 2 units. And again, I can use my Pythagorean theorem. My legs squared is going to be equal to my hypotenuse squared. That's 4 plus 9, or 13, equals AC squared. So AC would be the square root of 13, or also 3.6 approximately. So this is approximately 3.6. It says to calculate the measure of each angle in triangle ABC and DEF. So this is where I need to use my inverse trig. I do know that angle B, for example, is 90-degree angle. So let's first work on triangle ABC. So I know that the measure of angle B is 90 degrees, but I don't know the measure of angle A, nor do I know the measure of angle C. So I could use my inverse trig to help me with that, since I know my side lengths. Let's pick A. It doesn't matter. You got to pick A or you got to pick C. These are my inverse trig steps. Remember, my first one was to choose an angle. I'm choosing A. Then it was to pick a trig function. Technically, since you know all the sides, you could use sine, cosine, or tangent. I'm going to use tangent of A. The reason I'm picking tangent over sine or cosine is I get to use the 2 and the 3, and not my 3.6, which is a rounded number. It's not an exact answer. It will mess with my angle measurements a little bit. So I don't want to deal with that. So I'm going to use tangent so I can use my 2 and 3, which are exact values. Tangent is opposite, which is 2, over my adjacent, which is 3 for angle A. So A is equal to tangent inverse of 2 over 3. When I pull out my calculator and I plug that into my calculator, I get approximately 33.7 degrees. 33.7 degrees. And if you remember, to get C, a quick thing I can do is I can do 90 minus A, because they have to add up to 90 degrees. And so C then would be equal to 56.3 degrees. If you are having trouble remembering this from our previous unit, come to office hours and I'll help you. This is where our trig just kind of pops up when we're doing this unit. So then we can do the exact same thing for our green triangle. It's actually the exact same work. If you notice, I need to pick F or D. It doesn't matter which one, but I need to pick. So let's pick D. And we're going to do all the same work again. I'm going to use tangent because I'd like to use the 2 and the 3. So tangent of D would be opposite, and the opposite of D is 2, over adjacent, which is the 3. So D equals tangent inverse of 2/3. And it's going to be the exact same math I had before, which is going to be 33.7 degrees for D. So the measure of angle, I forgot to write E in. We know that E is 90 degrees, so sorry about that, vertical, horizontal sides. And then the measure of angle D I just found to be 33.7 degrees. And just look on the other side, when I subtract that from 90, the measure of angle F is going to be 56.3 degrees. It says the triangles are congruent. How do you know this is true? So first of all, it's actually because of CP, corresponding parts of congruent triangles are congruent. But it's not just the angles. Remember, all 3 angles congruent means that the triangles are similar, not congruent. So this is also hinges on the fact that the 3 sides, the 3 corresponding sides are congruent. So it's not just because of the 3 angles, the 3 sides matter as well. And then let's remember our sequence of rigid motions that take one to the other. So let's find a sequence of rigid motions that would take triangle ABC to DEF. This again is easier to do with patty paper. If you haven't been to the classroom this week and you don't have it yet, no problem, you'll get that when you're in room. But on this one, you need to find a sequence of rigid motions. There's different answers that you could have. I'm just going to put one possibility down for now. You can check it out then when you get the patty paper. But I chose to rotate triangle ABC 90 degrees counterclockwise around B. What I did was get my triangle sitting the right direction. I needed to move my triangle so that it could slide on top of my other one. And so then finally now I'm going to translate it. And I chose to translate, I've got 3 different vertices I could pick from. I chose to translate along 5, 1 to -3, 3. Again, if you don't really remember that from last semester, if you need patty paper, if you have any issues, please don't hesitate to message me or let me know in Zoom what you need to finish off these notes. A couple of hints for the homework. When you look at number 1, it says to reflect triangle ABC over line x equals -3. So an x equals line is vertical at that number. So this x equals -3 is actually a vertical line at, you guessed it, x equals -3. And so you will reflect it over that line, and then you're going to translate it based on this vector, this distance, from 0, 0 to 4, 1. Thank you, and see you in class.